Good evening, ladies and gentlemen. Welcome to London South Bank University to the Institute of Refrigeration Presidential Address. It gives me great pleasure to introduce Professor Graeme Maidment, President of the Institute of Refrigeration. Graeme.
Well, good evening to you all. Nice to see so many friendly faces. I hope I'm able to say the same after questions tonight. It's my honour to be able to deliver the presidential address for the Institute of Refrigeration, and particularly to be able to do it on home turf, LSBU, with my colleagues and students and colleagues from the IOR, and also from the CIBSE ASHRAE group as well. So I'm really pleased to be able to deliver this. I'm going to talk about refrigeration into the future, and I pitched it at a level for those that know something about refrigeration and also those that know perhaps a little less about refrigeration. So it's pitched quite general. So the content of my presentation is why we're important as an industry, why we provide a vital role for society, how we contribute to the economy, how we contribute to the environment, and to look ahead to how we will be in maybe 2020, or what we should be in 2020. I want to start with why we are vital to society, and I've got here a bit of a mosaic of images I've captured from the internet, and these are applications that contribute so much to our lives, and we start off in the left-hand corner with the pear, and that symbolises food manufacturing and storage, and drink manufacturing and storage. And refrigeration is a critical part, and without refrigeration our lives would be so different in terms of food. And then we've got the domestic fridge, and then we've got manufacturing in the UK, a whole range of chemical and drug manufacturing, and other manufacturing is so reliant on refrigeration. And then we've got an operating theatre, and then we've got a baby that's been operated on, that's having their brain cooled, okay, to keep them alive while they're being operated. And then we've got the typhoon, and the typhoon is able to survive under combat because of cooling. Without it, it would be gone very, very quickly. And then we've got space exploration, and the one after that is a data centre. And data centres work because they're cool. Without being cold, refrigeration, they wouldn't work. And then we've got maybe some leisure facilities, and then we've got someone that's got a bit of a problem. Because they've been in an environment that isn't cooled properly. And then we've got artifacts that require cooling and conditioning. And the last one is probably the biggest and most important one for us as an industry moving forward, and that is heat pumps, refrigeration for heating. So that's what we do today, and actually we're not standing still. There's other things that are going on as well in the future. And we will expand, we will increase what we do. And this is a list of some of the things that I think we're going to grow into. And down the right-hand side are some diagrams. But let's go through some of these. But local manufacturing is a critical part of government policy on rebalancing the economy, away from service and the finance sector to more localised manufacturing. And that must impact on us as an industry. There's going to be new chemicals and drugs that are going to need cooling. Domestic cooling. Does anyone know what the green and grey thing is in the middle there? Anyone know what that's called? It's a food store. It's called Shopbox. Okay, and you can buy that from every single retailer. And I think these things are, well, they're coming. It's a way of providing cooling for your food whilst they distribute it at your home or you're out. Okay, and you can rent these for less than the cost of the delivery. Then the picture next to that is someone under some ice, just about to be operated on. Okay, it helps the operation process, the recovery process, actually cooling the person down. Defence, the soldier there has got a cooling vest on, and it means that they can, in the fields, they can survive for much longer, okay, in hot climates. Other things that are going to happen are growth in electronic cooling. This diagram here, does anybody know what this is? Cooling of wires. Why would we want to cool wires? Anyone any idea? Superconductivity. Okay. If we make certain materials cold enough, okay, they can become superconductive electrically. There aren't any losses. Okay. And this is a superconductive cable, and it's got nitrogen in there to about minus 100 degrees C. Okay, this is happening. What else we've got? Growth in data centres, continuous growth is going to be, internet shopping, more demand for air conditioning, and, as I've said, massive expansion of heat pumps. So we're not standing still. Now, whilst I was looking, I thought they were on the internet for applications. I found some interesting ones as well, which you may want to, I thought I'd share with you. This is a patio air conditioner for the barbecue. That's someone's portable ice bar. Tent air conditioner. This one's a good one. This is a cold sheet for sleeping on. A cold jacket. And my favourite one is a dog cooler. Seriously, we are important because we contribute to the economy. We contribute massively to the economy. Directly, 2.4 billion, 1 in 1,000 jobs, manufacturing plus service maintenance, etc. Indirectly, even bigger. We underpin many sectors. 70% of foods are chilled or frozen, and refrigeration is really important in preventing waste. And we've all seen the cost of our shopping go up. Waste and minimising waste is going to be really important for us in the future. The economy is important, but there are two challenges ahead that I'd like to highlight. Firstly, population growth and resource availability, and secondly, climate change. Population growth. I don't know if anyone's seen these sorts of diagrams before, but these show projections in population. From today, we've got 7 billion. Okay, we've got 3 different scenarios. One, this continuous growth, this median condition, and we all kill ourselves. Based upon the median predictions, we're predicted to grow from 7 billion in 2011 to 9 billion in 2050. But the most important point about that is the actual change in the demographics will be really important. So out of that, currently 3 billion of the developing world will become developed. Okay, so they will become consumers, and as a result they will consume more materials, commodities, energy, water, buildings, etc. So the tension on materials and demand on materials will increase massively over the next 50 years, and we will see that. That's historical commodity prices, and you can see that we've had up until 2000 we've had a reduction, but in 2000 it's gone mad, and the predictions are that it will continue to go mad, and costs up by 1/3 by 2020. Okay, so materials will continue to get more expensive. How will we respond? Less waste, more recycling, reuse and remanufacturing. Those are not my words, those are government words. Okay, and there is a government policy document that was produced in December called Reducing and Managing Waste, and this talks about a zero waste economy. Okay, so it's coming. To help with that, Something we should consider is leasing of equipment, because that allows remanufacturing, reuse, etc. And there's a nice little case study about washing machines in the paper. You can look at it later. Climate change, that's my other challenge for the future. And these diagrams I've presented to some of you before, and I apologise for that, but these show temperatures that are potentially going to happen, predicted to happen in 2080, under the low emission scenario on the left and the high emission scenario on the right. So potentially climate's going to change from between 2 degrees C or to 5 degrees C in London over the next 50, 60, 70 years. We've seen weather extreme conditions, and I did a good Google search the last few days, and I found over the last decade or so we've seen changes or extremes in temperature, records being set, high temperatures and low temperatures as well. And in the States at the moment, I've taken this picture from the internet. This is one of the seas or the rivers, okay, that's frozen. It's abnormal in the States. And we've seen in the last few days, haven't we, last few weeks, wet weather as well. So it's not just about temperature, it's about precipitation as well. And this slide shows the potential change in rain under high emissions from 20 to 2080. This is winter and summer, and you can see in winter we're looking at increased rainfall, summer we're looking at less rainfall. So flood, drought, flood, drought. Predictions, are they true? I don't know. But we've seen that, haven't we, relatively regularly last few weeks. And this is actually the Environment Agency floodplain, and we're about there. So from Miriam upwards, you're okay when it starts raining in about an hour. Some people say it's a one-off, okay, and I evidence against that, okay. If you look at the Thames barrier closings, this was a flood defence to help protect us as protect London. It was constructed in '83, and it was suggested it would close once a year, okay. And these are the closings that are reported on Wiki anyway. And you can see 2003 there was 19 closings. Do you know how many closings there's been in 2014? It's 11. Is that right? Or is it more? No, it's 11 yesterday. 11 yesterday. They were going to 14 consecutive. 14 consecutive in the first few weeks of January. So that's evidence to show that there is something going on. Well, some people put it down to greenhouse gas emissions, global warming, and the gases that are responsible for that, we're told that 6 greenhouse gases include carbon dioxide and HFCs, hydrofluorocarbons, which we currently use in refrigeration. So refrigeration is responsible for these gases. My question to you is, which has the greatest impact for greenhouse gas emissions? Refrigeration and air conditioning, or air transport? What do you think? Now, air conditioning, okay. Well, you can get your phones out, okay. You can vote. Seriously, you can vote. So get your phones out and put into your phone, text the number. So you text 020 332 5822, and if you think that refrigeration and air conditioning has the same contribution to CO2 emissions as air transport, you can use the top number into the text. If it's twice the amount, you put the middle number. If RAC uses half the amount of air transport, use the bottom number. You know what to do? On a worldwide level, yeah. Do I know the answer? Hang on, hang on, hang on. There we go. Oh, we've got some votes already. Can you see the number there? Yeah. So which is correct? Does refrigeration air conditioning produce more greenhouse gases? The same amount? Does it produce more, or does it produce less than air transport? We're split at the moment. You can try if you can't. Send you a text back saying. Okay, we'll leave it a little bit just to make sure everyone's a chance to vote. Oh. So there's a split, it looks like. But the winner at the moment is RAC produces half the amount of greenhouse gas as air transport. Oh. Yeah, it's the air transport's winning. Okay, we will. Yeah, looks like we're getting there. Okay, we'll come back and have a look at that in a bit, just to check what the final results are. What's the answer? The answer is refrigeration and air conditioning produces twice the amount of greenhouse gas emissions than air transport. Twice. Miriam, you want to? That one. And to be precise, never work with computers. Ah, there we go. To be precise, we produce 10% of all greenhouse gas emissions. 16% of all UK electricity. How do we produce that? We produce that in two ways. We use electricity and then we emit CO2 at a power station, but we also leak, or we can leak refrigerant, and these refrigerants are potentially greenhouse gases. The proportion between the two, 3/4 is due to energy and 1/4 due to leakage. So we're a big emitter, and therefore we have a big responsibility to reduce our emissions. And UK government signed up to the Climate Change Act, which said we would reduce our carbon footprint by 80% by 2050. And to do that, we have a responsibility as a refrigeration industry. And we are doing that directly through reduced leakage and phase down of high global warming gases. But the indirect is the biggest amount, and that's the one we have to address. Indirectly, we can reduce our emissions through three ways: reduced need for cooling, increased efficiency, and using low carbon electricity. And as an academic, I like an equation. And my equation says that an 80% reduction can be achieved by using a product of 0.6, 0.6 and 0.6 to give me 0.216. Therefore, if I reduce this to 60%, I increase this by 40%, reduce this by 40%, okay, I can get to a 20%, okay, by just working all these three things together. That's really important, okay, really important to work on those three things together. So how would I reduce the need for cooling? Well, if I had a building or this is a cold store, I would close the door. Okay, we close the door, let the cold stay in. Or we would make sure that the insulation is appropriate thickness, and we make sure it works. This is a thermography picture showing a cold store, showing that some cold bridging. Or we would keep the sun out with some shading. Or we would make sure that we used low energy internal lighting to reduce the load in the first place. And the final thing we would do is we would buy the best piece of equipment we can in the first instance. So for instance, supermarket display cabinet. We'd see these, there's thousands of these in the country. Okay, this here is a bit of a busy slide, but it shows the energy consumption and this display area for a number of different refrigerators, display cabinets. Ones I'm interested in, these green triangles, and I'm specifically interested in these two here. And this is Judith Evans' work, by the way. Judith is back there. But you can see this one here has got a total energy consumption of nearly 60 kilowatt hours per 24 hours, whereas this one here is probably about 6. Okay, so if I choose this one, my demand is 10 times that of this one. But they do exactly the same thing. Which one does the customer buy? The cheapest. And which one is the cheapest? The top one. Okay, so it's really important we buy the right piece of kit to start with. We also need to look at how we can improve coefficient of performance, and we can do that by considering the temperature lift between the condensing temperatures and the evaporation temperatures. And this is in our gift as designers. Okay, we can vary these. This is a slide showing the difference between COP and temperature lift, and some of the more traditional books that we use give optimum values. Okay, and this is an optimum value from one particular book. But actually, these values were determined 15, 20 years ago when energy prices were different to what they are today. And actually, we could probably move up to there and have a much higher COP. Okay, it may cost us a bit more money, but we can achieve much higher COP. So we need to revisit these norms. And the evidence to show that we have the capability to do that is this slide here, which compares the COP of some air conditioners that were found in the UK compared to the similar products in Japan. It's not actually COP, it's EER, but you can see here, these are the UK ones. Okay, the COP is much lower than the Japanese versions. Okay, so it's achievable. We can also increase COP through integration, and this is an area which we really need to work on. Integrated heating and cooling. This is a diagram showing the components of a refrigeration system, evaporator, compressor, condenser, expansion device, and it shows some typical heat and energies that are going in. COP in cooling load is the cooling capacity 4 divided by the compressor input 1. So it's 4. In heating mode, 5 divided by 1. In cooling and heating mode, we can get 9. And we need to try and work on how we can achieve those sorts of COPs. Maybe sharing heat with someone else while we use the cooling. And what we must do, and this is a no-brainer, okay, we must insist that our chiller manufacturers install these superheaters on our hot water, okay, so that we have hot waters produced at the same time we have cooling. And this is the superheater, it's in the paper. Heat pumps are really important for the future. And this slide here shows the carbon kilograms of CO2 produced per 100 kilowatt hours of heat for a boiler, and a heat pump based upon today's efficiency and carbon factor from the grid. In the future, as we use more nuclear and more renewables, the carbon factor of the grid will go down. So in the future, this is the carbon that's going to be produced. And if you go to 2035, potentially, we've got a fifth of the carbon or less for conventional boilers. So refrigeration can effectively minimise the carbon that's produced from heating. And the final thing that I wanted to talk about in terms of improving our efficiency was to use low carbon electricity. So it's picking up on the same thing, and these are the carbon factors that are potentially going to happen in the future. We're currently here, 2012, we've got carbon factors for electricity of 0.5, but it's going to drop and drop and drop until it's 0.05, something like that. Why do we think that's going to happen? Because that's what's in our legislation. That's what the Climate Change Act says, 80% reduction of carbon by 2050, and the Energy Bill says we're going to achieve that by decarbonising our electricity grid. So we're going to achieve that through low carbon technologies and nuclear power. Is this a good way of working? Well, DEC seem to think it is, and they've produced lots and lots of models, and they've actually modelled cooling until 2050, and they think actually cooling demand is best just keeping it as it is. So this is cooling here, keeping the demand constant, and achieving our reduction through nuclear and renewables. I don't agree with that. I think we should be doing something different, because I think this policy is too focused on renewables and nuclear. And if you look at renewables, the cost of renewables, PV, as we see on many homes, is expensive, £800 per tonne CO2, whereas the cost of abatement of energy efficiency and refrigeration is much less. So the government should be investing money, more money, in energy efficiency schemes rather than PV that publicly is very obvious. But if they invested the same amount of money into energy efficiency in refrigeration, it would have much bigger impact. Looking forward, without any significant incentives, how are we going to change, and how are we going to move forward? And I've highlighted two enablers. The first one is money. Money makes things happen, okay? And if we can tune in money with reducing carbon emissions, we can deliver carbon emissions. And this was a subject of David Bostock's presentation recently to the IOR. If we aim at reducing money at the same time as reducing our environmental impact, we can do the right thing for the wrong reasons. Okay, so that's one enabler we should look at. And the second thing is best practice engineering. Okay, there's lots of good stuff that we do, but we need to do more of it. And again, this was highlighted at a recent conference by Brian Churchill of ASDA. And I want to give a couple of examples of where I think money and best practice will be so important for us as an industry moving forward. The first one is how we purchase refrigeration equipment. How do we purchase? What do we use as the main criteria for deciding about a purchase of refrigeration equipment? The cheapest. That's right. We purchase often on capital costs at the expense of energy. And as we've seen with Judith's graph earlier on, we can buy exactly the same piece of kit, one that uses 8 times more energy than the other. Which one do we buy? We buy the cheapest. However, if you look at the life cycle, the cost of the over the life cycle is not is not dominated by the equipment installation or the service and maintenance. It's dominated by energy. And therefore, if we do a life cycle calculation, it's much better than making an objective choice. Much better getting the best system. So life cycle techniques are really important. And if you look at this guide, it's got some really good life cycle techniques within it. New technologies. Again, there's lots of new technologies that are coming on. There's the refrigeration roadmap, and it's produced by the BRA and the IOR in collaboration with the Carbon Trust. And one of the critical things about it is it shows how much carbon you can save and also how much money things cost. Okay? Cost of failure, reliability is really important. And this is some work which we've been doing with the IOR over a number of years, but looking at refrigerant leakage. What happens if you get a leak in this case, a supermarket? Well, typically, Christina's here, she found that by looking at 1,500 supermarket records, if you get a leak in a supermarket of refrigerant, you lose 20 kilograms of R404A in this instance. That has a cost, £300. There's also a cost of repair, £500. There's also a stock loss. And my colleague Akosh, I asked him one day to go to Tesco's in Brixton and can you go to the Tesco cabinet and work out how much food is in the cabinet? And he did it. He came back the next day. He said this cabinet on the bottom has got £4,000 worth of food in it, and the one above's got £2,000 worth of food in it. It's right in there. Yeah. And if your refrigeration system goes down, you lose £2,000 worth of food, and the cost of the carbon as well, and you lose £4,000 for one leak. So put it into monetary terms, it has a much bigger impact. However, if you put it into carbon terms as well, 20 kilograms of R404A is equivalent to 80,000 tonnes of CO2. That's something like 20 times what I would produce at home, my family would produce. So 20 families for one leak per year. 20,000, sorry. Same as my family for a whole year. Okay, so 20 families for a year is the same as one leak. Okay, it's massive. And the final thing I wanted to highlight in terms of economic best practice is maintenance, proactive maintenance and partnerships. And this shows, Brian Churchyard and John Bonner's not here, but this shows the work that they've been doing together with ASDA over the last 10 years. And they've got their refrigerant leakage down by from 54 to 7%. And at the same time, they've saved money. So because their service engineers are now covering more stores and the cost of leakage has gone down. Okay, so it's a win-win situation, proactive maintenance and partnerships. And this is what they've done. This is ASDA, I think. This is their leakage rate. And again, this is a figure from Christina's work based upon some data that she had. She looked at which stores were the ones that were leaking the most. And she targeted. It's not difficult, and able to target the ones that are leaking the most. Good engineering practice. Okay, so the last part of my talk, I wanted to talk about resourcing our profession. And when I thought about resourcing our profession, I wanted to think about what our profession might look like, what a cooling industry might look like in 2020. And I couldn't find a picture of what our cooling industry might look like in 2020. So I found one that it shouldn't look like. Okay, and this shows me everything about what we shouldn't do in cooling. Okay, random. Okay, ill-considered, badly installed, unable to service and maintenance, all of those things. And actually what we should be doing is these things. We should be minimizing cooling. We should be working with new refrigerants. We should be ensuring that our systems have high efficiency in delivering cooling and heating together. We should make sure that our cooling systems
and our heating systems integrate with renewable technology. We should share our heat with our neighbours. Dynamic control, we should store. Proactive maintenance, we should recycle, remanufacture and reuse. And that's what I think our industry should head towards if we're going to meet our obligations in the future. How are we going to do this? Well, I put down a list of things that I thought were important for us as an industry. And ultimately, we need to have good fundamentals. We also need to recognise, acknowledge that actually we're a really important industry for society. And we need to tell the world we're important. Okay? We're not metal bashers. Okay? We're a really important industry that perform a fantastic service for society. And we need to tell the world that. We need to make use of the best IT. And to these young guys at the back, okay? My daughter does all these things with the mobile phones and whatever, and there's fantastic things that you can do with these things these days, and you need to try and bring that into our industry, okay? Because it's got massive opportunity. We need to be able to communicate effectively with customers and end users. So if they decide they want to do something silly, you need to be able to tell them, actually, are you aware if you do that, it's going to cost you this amount of money per year? It's silly. You know, those sorts of things. And to work closely with other trades and professions, integration, but we also need to be able to adapt and learn new skills as they evolve. Recently, this guy, Doug Richards, Lord Richards, produced an apprenticeships report. And what he said was, industry need to take greater ownership of both standards and delivery of education. And I'm pleased to say that the IOR is reinstating its education and training committee, and with the aim of working with industry to do this. Okay, so that we're delivering the right skills for the future. So looking forward, we need to also be aware of what we've currently got. Our sector is not very diverse. 23,000. Mostly white male, less than 1% female. Small businesses, very few ethnic minorities. And we've got a lot of old people. And this is the closest I could get to demographic distribution of our industry. This is MIMechE, Institute of Mechanical Engineers. And I looked at 1988 data, 2003 data, and 2010 data. And basically, all you can see is this sort of moving each time. Okay, the peak moves like the number of years. Yeah, so from 1988 to 2013, the peak moves 13 years. Yeah, from 2003 to 2010, the peak moves 7 years. Okay, so we've got this this movement of demographics all the way out, okay? And we need to replace that and grow. And that's why you guys at the back, okay, are so important. How do we attract young people? Well, I put down here the reasons. Money. Okay, and there must be, with demand, if demand continues, there must be fantastic salaries. Long-term salaries. Global warming is not going to go away. There's going to be variety, because every application is different. When I was an apprentice, working with Tony, one moment we were somewhere, next moment we were somewhere else. You're there now, and I'm here. And it's a fantastic world opportunity, and we have the opportunity to save the world. Okay, that's a bit cheesy, but it's true, to make a difference. However, we're not the only industry that's trying to grab these young people. Okay, there's other science, engineering, technology industries are trying to grab, and by 2020, 1.2 million new people need to come into science, engineering, technology. Okay, that's 100,000 a year and 60,000 apprentices. Why would they want to come into refrigeration? And actually, if you speak to them, and this is some work which was done by Nottingham Trent University and Sam Newman at WR just before. She did some work looking at why engineering science graduates could come into our industry, and she surveyed a number of them, and only a few have ever considered coming into our industry. We're not very well known, we're not very glamorous, we haven't got adequate information, okay? Not very many perceptions of our industry. Perceived careers that are glamorous are these. And actually, Sam also looked at their workforce at WR and why individuals ended up in their industry. And if you take out being 2P'd in, okay, most individuals in that company ended up in the industry because they're friends and family. Okay? And to be fair, I'm standing here today because of this man. Okay? Leonard Barley. Okay? And Leonard Barley came here, Borough Polytechnic Institute. Okay? And he was here in 1932. He was my granddad. Okay? And he was chief engineer for the co-op. Okay? So the reason I ended up in refrigeration was because of him. But actually, I think we can do better than that. We can make sure that we extend our tentacles to make sure that we tell not just our friends and family, all backgrounds, and we extend where we communicate to that there is a fantastic opportunity here. I'm nearly finished. So what can we do? Well, at the IOR, we've been trying to do a number of things, okay? But we need your support, okay? Those members that are active, we need your support to get involved in a number of range of things. We have some material available, the Careers in Cooling video, which I'll play in a bit, and there's some PowerPoint presentations, and we run some Young Engineers Network. But we need to be able to communicate to young people that it's a fantastic career. And it's not just going to be one person that does it, it has to be an army. This one here is an interesting one, and this is my old school, Wilmans Grammar. And just as you go into the entrance of Wilmans Grammar, they've actually got these companies now sponsoring. These are huge, great banners. These are 8-foot banners. Okay, this is Caterham Cars, which is made in Dartford. Okay, they sponsor the school. And this one is a company called White Code Design Associates. And White Code is run by Alex Hill, who also went to Wilmans Grammar, but he also came here. And he's got a massive, great poster at Wilmington Grammar School. How good is that? So it can be done. There can be better interaction. So, just before I finish, we've got another one. And I just want you to spend a bit of time, if you can, on your phones, okay, between now and later. What else can we do to recruit young people? Okay, so we're doing it now. On your phones, what else can we do as an industry to recruit young people? And what you do is you type it, you send your message to 0203322 5822, and then you put text the number 86707, and then what do you think we should do? I'm interested in knowing what you think we should do to recruit more young people. We'll leave that running, okay, and I'll just finish off. So, I don't know how long I've taken, but to conclude, I wanted to say that we're a really important industry today, and we're a really, really, really important industry for tomorrow. Okay? We need to grow, we need to renew, we need to adapt. And to do that, we need skills and new blood to come into our industry. And it's not just an IOR thing, it's an industry thing.
we can provide some leadership, but we need some support from you. So
that's what I've got to say, and these are some acknowledgements of all the people that I've worked with over the years, and Joanne Hall gave me a fantastic opportunity as an apprentice and a whole range of things there, and I'm just going to leave playing our careers in cooling video so that you can, I'll turn it down so you don't hear it, but whilst we've got some questions, well, you don't want to, but you can see careers in cooling video. Those of you who don't know, it's there, it's fantastic. Miriam and Guy produced it, this guy. He's there. Miriam and Guy produced it 3 or 4 years ago. It's absolutely fantastic. So, direct people to it. Okay, that's all I've got to say. Thank you very much. So I think there's maybe a chance for...
Yes, if anyone would like to ask any questions now, Graeme will take questions from people.
Yeah,
Yeah. 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 So the question relates to the graph that I produced that I showed that showed COP of Japanese air conditioners compared to UK air conditioners, and the question is, why, if the air conditioners were probably from Japan, why weren't they the same? This wasn't. I'm reporting someone else's work, okay, and it was done as on behalf of Roger Hitchin did it on behalf of Harmonech. But what he did was he went to Japan and he surveyed pieces of kit in distributors, and he did exact same thing in the UK, and he found those differences. And I think the reason he found it was because that's what we want in the UK. We want effectively cheaper capital cost, or there's less emphasis on capital cost, and in Japan maybe there's more emphasis on energy, and as a result there is a different product.
Can I make a comment about the
Can you give your name and where you're from? Will you ask a question, please?
David Butler from BRE, Roger Hitchin and my colleagues. I believe this study was looking at some domestic portable air conditioners, so the room units on a set of casters. And I think that the difference in the efficiency was in Japan to be able to sell premium products for a higher price, they have to have additional premium features to be able to charge a higher price, and one of which happens to be a higher efficiency. They were significantly more expensive products in a lot of cases than the cheaper products that are sold in the UK, which quite often sold through the likes of the DIY sheds and electrical shops. So I think it's potentially a little bit misleading. It shows what the technology, what you can achieve with the technology, but there's a price to pay for that.
Absolutely. Yeah. Tim.
Tim Dwyer, Chair of the Suggestion Group. Graeme, you said one of the ways is to throw money at this. The government's going to be throwing money at air-to-water heat pumps soon with an RHI. Is that a great way to use our money to move forward in the refrigeration world?
I think heat pumps are fantastic things, but heat pumps need to be applied in the right way. And there was a study that was done last year and the year before by DEC, which went out and measured a number of different heat pump installations in the UK. And they found COPs were 1, 1.5, 2, those sorts of levels. And if you've got a really rubbish COP, you don't save any carbon, okay, or money. It actually costs you money, okay. So the devil is in the detail. If you get the equipment right, okay, and specified in the right way, then there is a fantastic opportunity to save carbon and save energy. But the detail is important. COP is important. At the same time, we have to deal with the grid. The grid has to be able to deal with this, and the network. So there are other challenges as well. And if you apply the heat pump in your home, is it going to be able to also work with your existing radiator system? So there's a number of different technical challenges as well. But in principle, if you get the detail right, as my diagrams showed, you can save significant amounts of carbon as we go to a decarbonised electricity supply. Andy.
Andy Pearson from Star Refrigeration. Thanks, Graeme. You did a great future look with the comments on population and energy. There is a third dimension to that, which is fresh water, that we tend not to think about. And you made a very valid point. It is not just about population growing from 7 billion to 9 billion. It's about like middle class population within that growing by 3 billion. People moving from subsistence to consumers. And that means that the food supply in the world, if you do the arithmetic, actually has to double in that period. Now the problem is that currently 70% of fresh water in the world is used in agriculture. Therefore, we need to use 140% of fresh water in agriculture. So the question is, how can refrigeration and air conditioning also help to reduce fresh water consumption? Have you any thoughts on that?
I think you're right. I think water is a really important resource that we take for granted, and we should not, and it will become more expensive and more valued as a resource. I believe there are opportunities to use cooling for desalination of seawater, those sorts of things, in a polygeneration sort of way. So as well as using your heat pump for cooling and heating, you can use it for desalination as well. So there may be some opportunities there, but I think you're right. I think there is a real need for us to address not just energy and commodities and materials, but all natural resources as well. We have a problem. Yes, Andy.
Andy Ford from the South Bank and past president of City. I was very interested in that moving peak of people. I'm getting towards the bit that falls off the end. And your question about how we actually might improve our industry to the point where others might come into it. And I was thinking your great grandfather or your grandfather, I was wondering why he came in. What was it that was exciting at that time? And I was also looking at the 1% female, and I thought that is embarrassing, and no wonder nobody wants to go into this industry. So we have sitting next to me there's Andrew, who's from our Young Engineers Network and leads that. I would suggest that that's one way we could improve the situation. But why did your grandfather start?
Well, that's a really difficult question to answer, bearing in mind he's not with us today. But I think our economy was very geared to manufacturing, to world-leading engineering, and you know, our economy was built on engineering, wasn't it? In Industrial Revolution. 1750s onwards, you know, that's where we made our heritage. So I think it was a natural thing for people to go into, and that changed from the 60s, 70s onwards, 80s onwards, and there were many years when there was a demise and loss of manufacturing and those sorts of things, and it wasn't very trendy to get into engineering. And I think we need to turn the corner from that, and it needs to become a trendy thing to do, actually, to be an engineer. But I'd be interested to talk to Andrew, and the IOR has a Young Engineers Network, and I think we should work together as well, and maybe host some events. We have hosted a number of events so far, and it would be good to do some collaborative events.
Going on Monday, I was discussing this with
John Gallons, the president of the city, I didn't actually know what the proportion of male to female amongst our young engineers. Young engineers, that doesn't mean people by the way. That's from 35 years and under age group. And I'm not sure what the proportion of male to females is amongst our young engineers, but it's actually getting better. There's a greater shift.
Yeah.
There's more young ladies coming into doing service engineering because it's actually becoming a sort of job which is appealing to them. And actually, the point that Andy's just raised is that because there's more females, there's actually a greater attraction amongst the male population too.
Yeah, oh, I can see that, and I think the fact that we've got so few numbers of females in our industry, it becomes a sort of bit of a difficult, not clique to break. You know, if you're a young lady, you come into our industry, it can become quite difficult, I think. So, so if we can get some momentum there, then I think it will change. Lisa, you had something?
Yes, thank you, Graeme, for the presentation. You've highlighted a number of points in here. My question here is in two parts. It's regarding the strategic thinking forward as an industry. You've mentioned that decision making is really made based on cost, initially capital cost of recruitment. That's perhaps why we're getting this maybe negative image in terms of efficiency and performance of equipment. Perhaps also the leakage as well. The thinking forward, what strategic business plan do you think would put the industry back at the forefront of maybe being an entrepreneurial business plan that could be looked at forward? Is it a leasing that could be looked at in that way, or some other business model? My second part of that question is, we're now seeing a return of data centers because of data security towards Europe, and that's going to increase the refrigeration demand and the industry's perception of how it's performing. What are we going to do about this, and how's that going to affect our industry?
Okay, now I've forgotten the first question. Now, I think that life's, if you're making a business decision based upon some costs over a life, which most businesses do, you therefore have to consider those costs over the life. Now, at the moment, I believe it's quite difficult to actually get a life cycle cost from a supplier. So you phone up manufacturer, can you give me the capital cost is easy because they want to say it, but to actually give them the life cycle cost is more tricky. So if I was an end user, and I say this to my students, I would ask the manufacturer to give me the life cycle cost. Okay, so that's the start, is to actually ask the manufacturer for the life cycle cost. And if we do that, then manufacturers will start getting into the routine of providing that information and having that information. The leasing model is an interesting one, and I think for big businesses, there's an opportunity for them to save on capital expenditure. So that's an interesting one, but I think there are some technical or commercial problems with that. Data centers, moving data centers into central Europe, anywhere that's warmer, okay, is going to increase the cooling load, and we need to be smarter about how we cool these things. Maybe cooling them directly. Cooling a chip by air, which we circulate from somewhere else, is not a very good medium. And Gareth, where's Gareth? Gareth is one of the things he's working on is potentially cooling chips directly with foams and things like this, metal foams, evaporators. So I think there's an opportunity there.
Could I just highlight one thing? I don't know if I've taken perhaps some of these out this time. It was highlighted one of the meetings providing a service, the cooling becoming a service, rather than just providing an equipment that could do cooling. So
yeah,
that's why
yeah.
somebody, the equipment manufacturer, will be more responsible for the efficiency, the longevity, and
yeah, 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 yeah.
equipment.
So effectively, you make someone responsible for the life, the cost of the life. And if you do that, then they will then target the biggest cost, which is, if it's energy, they will bring that down, and in doing so, they will reduce the carbon emissions and so forth. Yeah, good idea. Yes, John.
Jonathan Davis, President of the Refrigeration Association, and also from the Equity Group, and this is more comments than questions, please, on the discussion that's just taken place. Sorry, I should have said that was an excellent presentation. Thank you, Graeme. Very thoughtful. Certainly that point about the equipment manufacturer providing life cycle information, particularly on energy, is valid. But speaking as a manufacturer, one of the difficulties there is that you can almost make the answer anything you want.
Sure.
What is the weather going to be?
Sure.
There are so many factors that go into it. And I think back to the time that TIWI was really starting to become a calculation tool for emissions, I'm guessing somewhere in the 90s. And the Institute of Refrigeration at the time put together a group that provided some parameters to provide a level baseline to be able to make energy efficiency calculations. And I think that's somewhere where the IOR, possibly the VRA as well, can work to provide that benchmark, so that when the manufacturer gives you an energy efficiency, it's always been calculated on the same basis, in the same way, same parameters, blah, 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 blah. Because honestly, I can give you almost any other responses you want. Now, you might say, okay, those discussions are taking place in the European environment today and with a view to providing energy labelling, but to be quite honest, one, that's been going on forever, and I think it's going to go on until I call off the end of the age spiral. Also, I've got real big question marks over how it's going to be policed, and I also actually think it's got that far away from the real world that the figures that come out of it are going to be meaningless. And at the risk of just going on a little bit too long, which I'm always in danger of, but you do have to be very careful about defining what those parameters are, because if I take two pieces of equipment at design conditions, and one is 20% less efficient than the other, then at lesser design conditions, one's probably going to be 20%. So doesn't that make the decision easy? No, it doesn't, because what you're trying to do actually is to identify what the payback is for perhaps a little bit more capital cost. So 20% is pretty meaningless unless you can actually define what that means in the financial states. But I think there's a lot that the VRA can do to provide that level playing field. Maybe that means that the UK are sort of doing their own thing on an island outside of Europe, but somebody's going to do it properly.
We do that a lot anyway, don't we? But no, it's a really, really good point, and yeah, I think providing some support is a good suggestion, and maybe we should have a discussion about that after. Yeah. Okay. Andrew.
Andrew Geagle, CCC Consultants. Graeme, you gave lots of interesting information and facts about our industry this evening, but hopefully you are preaching to the already knowledgeable, hopefully, and possibly the converted. We've already acknowledged the problem comes in the low status we have. We do lots of important stuff, and no one outside the bloody door there knows we're doing any of it. It just works. And it seems to me that somewhere on the line we need to do something to actually raise our profile so the Sun, the Mirror, the Daily Express, the BBC actually knows how important refrigeration is. John Humphreys knew how important refrigeration was to his bloody career, I think he'd treat it very, very differently. I mean, we need to find some way of addressing that problem, I think.
Yeah, I think it's a really important issue that we raised. I don't know if you saw the BBC4 thing that we did on the 20th of December. Have a look. Oh, you don't watch television.
No.
So that's why you don't know what's going on. BBC4, 20th of December, there was a programme on 10 minutes on refrigeration. It's really good. But I think you're right. I think we do need to get ourselves out there. I think Andy Pearson said to me once, the best way of informing the public about something is to get it in an episode of Coronation Street. And we need to do that. And funny enough, I wrote to Daily Mail and Daily Express and a number of these newspapers. They have a one weekly article on careers. And I wrote a sort of an editorial page about careers in refrigeration. You know, it's fantastic, whatever. And I sent it to them on the hottest day of the year last year. I sent it to all of them, and they ignored me. So, you know, we need to try and maybe go again and see if we can get some traction. But I think there is an opportunity there to make some progress nationally. Harry.
Harry Lawler from London South Bank University. I was just, the way you're trying to inspire the Institute to think about contributions to global warming, climate change, those sorts of things. It's a real risk, but just bring a couple of bits of information together. Being really simplistic, the refrigerator that I'm going to buy from the IOR shop in 2050 has to use 20% of the energy compared to the refrigerator I bought in 1990. The OECD predicts that between 1990 and 2050, world energy consumption per capita will increase by a factor of 5, largely because of what's happening in China, India, and South America. But in Europe and the West, where the economy is looking deflated in 2008, our energy consumption from 1990 to 2050 per capita will double. So what Andy said about the food, extra refrigeration for food, more refrigeration in offices, my dog cooler, and all those sorts of bits and pieces. I'm going to use twice as much energy on refrigeration. So my fridge actually has to use 1/10 of the energy that it used to use. I think it's going to be a much, much bigger problem than people foresee it to be. Yeah. Carbon emissions down.
Yeah. So it's a big problem, and we need to best people. So I'm really pleased to see these guys back here tonight, and thank you so much. Thank you for bringing all these youngsters from South Thames College, because we need you. You're important. Okay.
We're not going to pay them though.
Pardon?
We're not going to pay them though.
We are. They're going to be there. They will be paid very well coming into our industry. Global warming is not going to go away, and it's going to need smart people to solve the problem. Okay, smart people hopefully will earn a good living for a long time.
What a positive way to finish it. Thank you, Graeme. Well, it's my honour just to finish off this evening. My name is Tim Dwyer. I'm the chair of the Subsidiary Group. We're co-sponsoring this evening's presentation by Professor Maidment, and it's a real pleasure to be here. As many of you know, I've worked with Graeme for many years, and it's particularly apposite that we're in this room. The Nelson Hayden lecture theatre, of course, the Hayden family going back, well, it would be 200 years just about if the company not switched names just a few years ago. And that shows a great legacy that is being carried forward by the work that Graeme's doing here. And it was wonderful to see such a fantastic cross-section of that work being displayed today. And it really came to me, the real word there was communication. It was a matter of spreading the word, not just between ourselves, as was said earlier, but outside of here. And we all should be spreading that word and using some of those great examples that Graeme showed us this evening. And interestingly, the Nelson Hayden,
the part of the Melton, the Hayden family, but this particular electrician was named after. He received the gold medal from CIDSE in 1959, the highest honour in CIDSE. And he in his citation for that gold medal, it said he built well on the foundations that predecessors had laid. Well, I think we can clearly see that Graeme is building well on the foundations that predecessors have laid, and it was wonderful to listen to Graeme tonight, and I look forward to all good work he'll carry on in his term in office and beyond as a presidential member of the Institute of Refrigeration. Well done, Graeme. Now I'd just like to pass across to Colin Lyons, who's got a few words to say.
So I'll make it very brief. Thank you very much. Really interesting presentation, very thought-provoking. Some good responses as well, I thought, from you guys. So. Right, two things for me to say. One is the next event is, it's actually a, how do you call it, it's not a discussion, it's debate, thank you. One particularly close to my heart, are doors on fridges the best environmental solution in the retail sector? John Austin Davis and Judy Evans as the opposite sides of the arguments. No? Judy?
From the co-op is the other side of the fence.
Okay, thank you. So that is on referee. Oh, you're regular referee. Okay. So that's on the 2nd of Feb, and that's at the I'll get it here in a moment. It's at the Queen Street address at LCCI, so the usual place. The only other thing I just wanted to say was looking, as always, for people to come along and do some presentations to us. So if you have any ideas, if anything particular you feel like you'd like to share with everybody, or maybe you know somebody who might have something to share, please can you just let us know. Either to myself or to Judith. I guess it will go through Judith. Sorry, we're in. I'm just going to shoot something. I guess we'll go through the IOR website anyway. So any ideas, please bring them forward.